do we have another part to go with this? For this one, again, we're going to go back to logic. I want you to think about a triangle. And I want you to think about listing the angles. In this case, it should be the angles. I got the diagram backwards. But think about listing them in increasing order. And based on nothing but the side lengths. So a better example of this would be this guy right here. Okay. Where we only have the side lengths and we don't know what the individual angles are. But it doesn't mean that I can't figure out the relative measures. You know, which one's the largest, which one's the smallest, which one's the in-between angle. It's actually really easy. If we think about it, think about the angle that's formed between my 2 m6 here. And the thing about the side, if I had a third side that was connected to these 2 points on the end. As that angle gets larger, what happens to that side? And it gets longer. As I make the angle smaller, my opposite side becomes shorter. So if I'm looking at a triangle, where would I find the longest side? So again, let's go back to these. If my angle is small, I'm going to have a shorter side. Opposite, shorter side. If my angle is really large, I'm going to have a really long opposite side. Keyword there is opposite. So where would I find the largest angle? Opposite of what? Not the vertex. Where would I find the largest angle for any triangle? That question. No? Sam?
The angle between your 2 spots.
Yeah, or opposite of the longest side. And that's what this is talking about right here. So the triangle angle inequality theorem says that the largest angle is opposite of the longest side. Let's write that down. The largest angle is opposite of the longest side. The largest angle is opposite of the longest side. So let's take a look down here at triangle DEF. And we want to list our angles in an increasing order. So what does that mean?
So,
No, that would be decreasing order. So smallest angle up to the largest. So where's my smallest angle, guys? If we're looking at this triangle, which angle is my smallest? Sam?
would it be E?
Okay, so angle EDF. No, Sam, why do you say that?
Because the difference between, it says 6 or 8.
That's an 8.
Yeah, so that difference is smaller between the difference between that and the others.
So you're making that way too hard. Sam, what's the shortest side on that triangle? The angle opposite of that is angle D. That's your smallest angle. That's all you got to do. Draw a line opposite. There you go. We're done. Okay. What's my next smallest side? So my next smallest side is 8. So therefore the angle opposite of that is F. So angle EFD. And the following, my largest angle, DEF. And we're done. It's really not that difficult, guys. Pretty straightforward. the largest angle is opposite to the longest side. So now, this is going to be a little trickier. Now what we're going to do, ask you guys to compare angle R, so angle R, and I want you to compare that to angle VSU. So VSU, so how do these two angles compare? Basically, tell me which ones, are they equal? Is one larger than the other? How do their measures compare? Do I have to know what their individual measures are? Okay, so guys, if we look at angle R and angle VSU, if you're going to compare them, you need to compare them inside the same triangle. So what triangle has both angle R and angle VSU? RUS. Okay, so now we're going to be looking at triangle RUS. Okay, and if I want to compare angle R to angle S, I need to only look at their opposite sides. So what's the opposite side of angle R? All the way across. 35. Okay, so that's opposite of angle R. Should have done that in red. Opposite of angle R. Now, what's opposite of angle VSU? 24. Okay, so which one's larger, the 35 or the 24? Okay, so then, how does angle R compare to angle VSU? Are they the same? Greater than. So angle R is greater than VSU. That's all I'm asking you to do that. By the way, with this concept, think about what we learned yesterday with isosceles triangles. Since my two sides are the same, what does that tell you about the opposite angles? They're also the same. And if you think about an equilateral triangle, since all three sides are the same, then all opposite angles would have to be the same. Alright, so that's why this kind of ties a little bit back to what we were talking about yesterday. Alright, any question with being able to list the angles in increasing order based on looking at the sides? Now, which is really neat, is the converse of this statement is also true. You guys remember that? Converse, inverse, and contrapositive. Remember doing those? Converse is where we switch the hypothesis and the conclusion. So, okay, so all we're going to do now is we're going to swap longest side for largest angle, and that's the last thing we're going to talk about today. So, where would I find the longest side of a triangle?